morning students. Today we will cover full subtractor. Now full subtractor is another combinational logic circuit. Now what is combinational logic circuit? In combinational logic circuits, the output at any state depends upon the present state inputs only, not upon the previous state output. So today we will cover full subtractor. Now what are the steps of designing any combinational logic circuits? There are 4 steps. The first step is to have the truth table for that particular circuit. Number 2 is to have the Kmap from the truth table. Now Kmap, when we are having the Kmap, we need to have the Kmap for each individual output lines. Okay, like in case of full adder, there are 2 output lines, sum and carry output. So we need to have 2 Kmaps, one for sum and one for carry. Now from each Kmap, we will derive the output expression, right? From the Kmap for sum, we will derive the output expression for sum, and from the Kmap for carry, we will derive the output expression for carry. Now similarly, in this case, in case of full subtractor, there are 2 output lines. One is the difference and another one is the borrow. So we will have 2 Kmap, one for difference and another one for borrow. Now number 3 is output expression. As I have said that we need to have output expression for each individual output line from the Kmap. So we will have 2 Kmaps here. One is for difference and one is for borrow. And from the Kmap for difference, we will have the output expression for difference, and from the Kmap for borrow, we will have the output expression for borrow, right? So to have the output expressions from the Kmaps. This is step 3. And step 4 is from those output expressions, we need to design our circuit. So there are 4 steps of designing any particular combinational circuits. So we will go for the first step, that is truth table. So we will see what is the truth table for a full subtractor. Now we will design the truth table for full subtractor. So there are 3 inputs. So what are the inputs? A, B and B in. A, B are 2 present bit inputs and B in is the borrow from the previous bit, right? And there are 2 output lines, one is difference and another one is borrow output or B out. Now, so as there are 3 inputs, so how many input combinations will be there? That will be 2 to the power of 3, that is 8, right? So what are the input combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So these are the 8 possible input combinations. Now we will have 2 outputs, difference and borrow out or B out, for each individual input combinations. So when we are calculating D and B out, then how to calculate it? The formula is A minus B minus B in, right? So first we need to do A minus B, difference of these 2. Then the result of that, from that result we need to subtract this B in, right? So first do the B out and D for the first input combinations, that is 0, 0, 0. So for the first one, A, B both are 0. A, B both are 0, 0. So what will be our difference and what will be our borrow? See, 0 minus 0. What is difference? 0 minus 0 is 0 and borrow is also 0, right? Now, so this is borrow and this is difference and this is borrow. From this we need to subtract this B in, minus B in. So minus 0, B in is 0. So what will be our output? The output is 0 minus 0, 0, and so difference is 0, borrow is also 0. So what will be D and B out for this particular input combination? That is 0, 0. Okay. Now come to the next step. This is This is our B in, right? Now come to the next step, that is 0, 0, 1. So 0 minus 0, 0 minus 0. From that we need to subtract 1 now for this input combination. So instead of 0, this will be 1. Right? So now see 0 minus 1. What is 0 minus 1? In binary subtraction, we have already covered in the subtraction class. If you have not attended that, then I will provide the link in the description box. Please go through that. 0 minus 1 in binary subtraction, it will give you difference 1, borrow 1. Right? So difference 1 and borrow is also 1. So what will be the output? Difference 1, B out 1. Now the next one is 0, 1, 0. So now B is 1. So 0 minus 1. 0 minus 1 is what? As I have already said, for 0 minus 1, difference is 1, borrow is 1. So in this case, this will be 1 and this will be 1. Because when we subtract 0 minus 1, your both difference and borrow will be 1, 1. Right? This is the binary subtraction rule. Now see, so in this case, we are subtracting 0 minus 1. So difference is 1 and borrow is 1. From that, we will subtract 0. So 0. So what will be the result? 1 minus 0. So output is 1 and this is also 1. 1 is remaining over there. So this is 1, 1. Right? Now come to the next combination. 0 minus 1 minus 1. 0, 1, 1. So 0 minus 1. A, B both are. A is 0, B is 1. So 0 minus 1. We are doing for this one, this input combination. 0, 1, 1. So A is 0, B is 1 and B in is 1. So A 0, B is 1. So do the difference. 0 minus 1 is difference 1, borrow 1 minus, what is your B in here? 1. So 1. So what will be your difference? Difference will now be 0 but borrow will remain 1. So what is the output for this one? That is 1, 0. Right? Now come to the next combination, that is 1, 0, 0. For 1, 0, 0, your A is 1, B is 0. Right? So do the subtraction. 1 minus 0. Difference is 1. Borrow is 0. Right? Now 1, 0, 0. Minus 0. In this case, B in is 0. Right? So minus 0. So 1 minus 0 is 1 and this will remain 0. So 0, 1. This is 0, 1. The next combination is 1, 0, 1. Right? So 1 minus 0. This is difference 1, borrow 0. Now minus 1. So minus 1. Here B in is 1. Minus 1. So 1 minus 1 is 0. So this is difference 0, borrow 0. Difference 0, borrow 0. The next one. 1, 1, 0. So 1 minus 1. 1 minus 1 will give you difference 0, borrow 0. Minus 0. So minus B in is 0. So minus 0. So difference 0, borrow 0. Right? So 0, 0. Now the next one. 1, 1, 1. So for 1, 1, 1, see 1 minus 1. So difference 0, borrow 0. Minus 1. So minus 1. Here B in is 1. Minus 1. So 0 minus 1 is what? Difference 1, borrow 1. So this will give you difference 1, borrow 1. Difference 1, borrow 1. So this is the truth table for full subtractor circuit, right? So we have done with the first part, that is to have the truth table. Now we will move to the next part, that is to design the Kmap for each individual output lines. Now here there are two output lines, one is difference and another one is B out. So we need to have two Kmap. One is difference, one is for difference and another one is for B out, right? So let's do the Kmap. So first we will do Kmap for B out and we will find out the expression for B out. Now see, there are 3 variables, so there will be a 3 input Kmap. So what will be the number of boxes? Number of boxes will be 2 to the power 3, 8. So this is a 3 variable Kmap. There are 8 boxes. Now we have put the MSB variable A in rows and other 2 variables B and B in columns, right? So these are the box number, orientation of box numbers. Now see, and this is covered in detail in our Kmap lecture. So please go through that. Now I will put that link in the description box. Now see, now we need to put the outputs for B out. So this is 0, 1, 1, 1, 0, 0, 0, 1. So this will be in box 0 because this is for input 0. Box 1, that is for input 1. Box 2, box 3, 4, 5, 6, 7. So we will put these values in respective boxes. So put them 0, 1. This is box 2. So 1, 1, 0, 0, 0, 1. Right? So we have put all these values in the respective boxes. Next, what we have to do? We have to group them up. Right? So see how to group them. What are the rules for grouping? The number of ones should be in power of 2. They should be in horizontal or vertical orientation and consecutive in consecutive position. There should not be any position gap. And vertical ones, diagonal ones cannot be in a group. And if ones are not in power of 2, they cannot be in a group, right? Now, following all these rules of Kmap grouping, we need to group them. So, see, these 2 ones can be in a group, right? Again, these 2 ones can be in a group. Again, these 2 ones can be in a group, right? Now, what will be the expression for this group? The expression for this group will be, see what is common for all the members of this group. This is our group, right? See, this is the group. So, what is common for all the members of this group? For both the ones, A bar is common from row. And from column, for these 2 ones, what is common? B in. So, what will be the expression for this group? That will be A bar, B in. Right? Now, for this group, see for this group. For this group, what is common? For both the members, both the ones of this group? B in. Because from rows, nothing is common. From column, B in. Right? Now see, for this group, for these 2 ones, what is common? For these 2 ones, see, from rows, A bar is common, from column, B is common. So, A bar, B. Right? So, what is the expression for B out? The expression will be B out. Just odd them up, all these group expressions, just odd them up. So, A bar B plus or A bar B in or B in. Right? A bar B, this is A bar B in, this is B in. So, this is the expression for B out. Now, we will do the Kmap for difference and we will find out the output expression for difference. Right? Now, see, we will do the Kmap for D or for the difference. Now, for that, the same way we have done the same Kmap for 3 variables. And what are the input variables? A, B, B. We have put A in rows, B in columns. Now, these are our box numbers. Now, let us put the values of D. 0, 1, 1, 0, 1, 0, 0, 1. So, let us put the values 0, 1, 1, 0, then 1, 0, 0, 1, 1, 0, 0, 1. Now, what is the next step? The next step is to do the grouping. So see, in this case, all these ones are distinct. So we cannot group them. Okay. So we need to write down the output expression for each individual ones, and we then have to add them up. So what is the expression for D? The expression will be, for this is A bar, B bar, BE. For this is odd, A bar, B, B in bar. For this is A, B bar, B in bar. And for this is A, B, B in. Right? Now we need to write down the expression properly to have the output expression, exact output expression. Right? So just derive this expression. How to derive it? See. Now see, this is our expression for difference from the Kmap. Now we will derive the expression in its true form or in its minimized form from this. So how to have that? See, just take A bar common from these two terms. From these two terms, I will take A bar common. So what will it be? If I take A bar common, then B bar B in plus B in bar. Right? Now take A common from these two ones. These two. Right? From these two. If I take A common plus A, so what will be in the bracket? B bar B in bar plus B in. Okay. Now what is B bar B in plus B in bar? That is B XOR B in. And what is B bar B in bar plus B in? That is B XOR B in. Right? So A bar, this is B XOR B in, and this is plus A. What is this? This is B XOR B in. Right? Now, what is XOR? That is complement of XOR. So, what is this? This is equal to A bar B XOR B in plus A B XOR B in whole complement. Right? So now what can I write? If I take B XOR B in equal to X, then what is this? Suppose here B XOR B in, let B XOR B in equal to X. Right? Then what will it give? This will give you A bar X plus A X bar, that is equal to A XOR X. Now just replace the value of X. What was X? X was equal to B XOR B in. Right? So replace that value. So what this will give you? A XOR B XOR B in. So this is the output expression for difference. Right? This is the exact output expression for difference. Now we are in our last step or in the fourth step. We have already derived the output expression for both the output lines, that is for difference and B out. So now in the final step we will draw our logic circuit by using these output expressions. Okay. So the logic circuit will be, what are the inputs for the logic circuits? The inputs will be A, B and BE. Right? Now see, there are three inputs. What are the input lines? A, B and BE. So draw the input lines A, B and BE. Right? Now see, what is difference? The difference is A XOR B XOR BE. So we can do it by using two input XOR gates. This is A XOR B and this is our B in. So the second XOR gate, this will give you A XOR B XOR B in, right? Now to have the B out, see what is the expression for B out? A bar B plus A bar B in plus B B in. So we need 3 AND gates, 3 2 input AND gates. One for A bar B, another one for A bar B in and for B B in. So let us use 3 2 input AND gates. The first one is A bar. So how to have the A bar? Just pass this A through a NOT gate. So this will give you A bar. So A bar B. This is your A bar B. Now A bar B in. So A bar B in. This is our A bar only and B in. Right? So A bar B in. This AND gate will give you A bar B in. Then B B in. So B, this is our B. B and this is B in. So B in. So B B in. So we have taken 3 AND gates and we are having A bar B in and B B in. Now either you can use a 3 input OR gate or you can use 2 input OR gates. So if this is a 3 input OR gates, then this will give you the output. This will add or this will OR them up, or all the 3 inputs, and this will give you A bar B plus A bar B in plus B B in. That is what? That is our B out. Right? And this is our difference. So we have derived the output logic circuit for full subtractor and for both the output lines, difference and B out. So this is for the today's class, and in the next class we will design a full adder using 2 half adder circuits. So till then, take care. Bye.